hey there. Welcome to SkyTour LiveStream. It is I, Mark D'Antonio, and as usual, in the background is Daryl Mason lurking back there. Hey Daryl, how's it going?
Hi, Mark. Mark. I'm lurking.
You're lurking, okay. I want to say hello to Daisy and Zoe Amethyst, and Lane is here with them. Hi Lane. I'm so glad you're with us. This is the Arizona scope we're looking at right now. We're waiting for it to get fully dark out there. We're not quite there. Tara D is here. Tara is the artist that created our door for the SkyTour LiveStream Observatory out there. She's amazing. And I just want to say hello to PG, who's here. PG, I'm going to see you in just a few days in Pine Bush, along with your husband. And we have, I saw Mike here. Isn't Mike here somewhere? And Satisfying Animations, SA as I call him. How you doing? Welcome. Nice to see you. Mike C is here. There's the guy I was talking about. And Anahata77, that's Bonnie. She's wonderful. Hi, Bonnie. How are you? It's so good to see you here as well. We're cranking away. The moon is going to be coming up, but see what we're doing is we started before the moon rises. And we're going to go do some cool things before the moon rise. That should be pretty cool. Did I say cool? All right. Now, for people that are here for the first time, this is the camera view here. This is the camera control system. Down below here, you can see a thermoelectric cooler. We actually have the camera cooled right now. The temperature of the camera is, looks like minus 6.3 Celsius. The target temperature is minus 10 Celsius. The cooler the camera is, the better the response and the less noise we'll see on the images that we take. And that's awesome. Okay. This location right here, okay, the cooler's right here. I can just get rid of the cooler controllers because we know what they are. We have them. But this is the important part right here. This is the exposure for the camera. And this is the gain. Think of the gain as the ISO, the sensitivity of the camera. If you have a camera, you set it to 800 ISO. Obviously, it's a little more sensitive than 25 ISO, right? And so think of the gain as being the ISO, but it doesn't have the same type of number system. 370 is pretty high, okay? And if you go up to 500, then you start seeing green in your images, kind of like you do with sensitive shots with the high ISO stuff. But this is a dedicated astronomy camera meant for taking color photos of imagery of the sky. And we're running our big telescope, which you see over here right above my head in the dome right there, actually in the building. That building is 2,500 miles away from me right here. And so everything we see is coming from 2,500 miles from me. It's really nice to do this. It's just so much cool. And Satisfying Animation saying was just out. You're stacking images while watching. That's cool. What did you take pictures of? SA. What did you take pictures of? Donald Kunzer, how you doing? Nice to see you. I'm glad that you're enjoying it, Bonnie. We've got some time here before the moon rises, and we're going to do this stream to try and capture a few really cool items. Right now, I only have a 1 second exposure going, so that it kind of looks like this, right? But where we are right now is actually, and where we should be, is actually on a nebula, a dark nebula in the Milky Way. And let's just to see if we can see it, let's go and do a 25 second shot, 25 seconds, and we'll stack it too, just to see how it looks. Okay. All right. Oh, and it's right. I got to start this over because I keep forgetting. I keep forgetting to do this. I want my image format isn't going to be what we call 8-bit. It's going to be 16-bit, so I have to select that. I want that to be the default, and I don't know why it won't default to that. Okay, well anyway, now we're starting over. We're stacking, and we're going to see some nice things. The other thing, too, is, and Daryl will vouch, we have seen our lion's share of satellites. They just seem to be going through like crazy. It's amazing. You know, one night I think we counted up to 20, right?
Oh, at least.
Yeah.
That wasn't very long either.
Yeah, it wasn't. Bria Lucia Campos, welcome. Hi there, and Adrian. Where's Adrian? And Crystals and Cats. All right. Very nice. I didn't see Adrian. Who's Adrian?
Oh, that was Donald Kunzler saying yo to me, so I said, yo, Adrian.
Yo, Adrian. Hey. Oh.
Yeah.
Okay.
Rocky.
I get it. Okay, I get it. Okay. Well, in this photo, this is just a 25-second photo, and look what you're seeing. This is a dark nebula in the Milky Way. This is part of something called the Dark Horse Nebula. And I set it on this just to give it a shot to see what we could see, and it does not disappoint. There it is. There it is right there. You can see these arching, beautiful clouds. These are many light years long. Isn't that incredible? So this is the beauty of the Arizona scope, man. We get to see the beauty of the universe right in front of your eyes. We don't have to wait for it to be processed. No more crappy looking images. We are done with that, folks. We are done with that. So I'm really proud of this. This is great. And this is just a test. I actually want to move us to several objects. There's 3 objects I want to do before the moon rises. And I'm hoping that the telescope behaves itself. It has been. So we're going to go up there and grab these. We want to get to... I want to get to the elephant's trunk. And we're coming to these right now. Here it is, the elephant's trunk. I also want to do, all right, let's see, elephant's trunk. We have elephant's trunk. I gotta maybe zoom in some more.
It's about where we left off the other night, wasn't it?
It was, yeah. And now, though, without the moon, it's gonna be a lot better.
Yeah.
Okay. And we're gonna do the Iris Nebula, the elephant's trunk, if we have time, and then the nebula that is here, which is known as the cocoon. But we'll start with the elephant's trunk, right? So I'm going to select it, and now we're going to tell the telescope to go there right now. If you watch over here, you'll see the telescope move, if all works well. So far, it has been. Okay, so there goes the telescope. It's now moving. And what I'm going to do, actually, is... I'm going to get out of this stack. Uh-oh. I don't know what it's doing. Okay, that doesn't look right to me. See, the telescope's going haywire right now. This is the crap I don't like. Alright, just a second. I gotta stop this. Why is it doing this? Come on. It was just working fine. And now it goes nuts. Not good. Oh my god.
Wow.
Yeah, I know.
Look like you're pointing due north.
It does, doesn't it?
Toward the northern horizon, that is.
Yeah, I don't like what it's doing. Oh my god.
This is, I mean...
It was working
sort of
just
what
fine.
happened before, isn't it?
Yeah, and this is not what I like. This is... I mean, why when it's working fine? It worked fine for 2 nights. Okay, well... This is crap. Alright, so here's what I'm going to do. Oh, proud of this thing working so well, and then it does that to me.
Question, what does your controller say down there in the lower left?
Well, it said that it was actually doing nothing crazy. Okay. I can't read what it's saying now.
I can't either.
Oh, come on. I'm concerned that maybe I've... Alright, I'm going to have to close some things down here now. Alright. Oh, error message. Wouldn't you know it? Oh, yes. Well, I hope we didn't go far enough to pull cables out. That would be great, huh? That would be just great. Oh, we got a trap 2 error on the telescope. Okay. At least I know what it did now. Alright. So that means that the telescope, I have to shut it off and restart it, and then we have to use the plate solve to find out where we are. But to do that, I am going to want to maximize this image so I see what the telescope's doing.
I was going to say, that was something that you learned before when it would act up, was that the whatever the controller there display message was, gave you a clue, wasn't it?
Yeah, so... Alright. I've never had the Trap 2 in a long time. I've had it before. But it looks like... Yeah, Trap 2 though, that tells me that tells me everything. So that so what I'm gonna do now. Yeah, welcome to Live Astronomy, guys. What I'm gonna do now is bring up this, and I'm going to see it says Trap 2 on the screen. That should go off when I do this. Actually, hold on. It probably won't. I don't even think the telescope's actually connected now. I can't tell which. Wait a minute. I can't tell which way it's pointing either. Yeah, it's not. Yeah. Okay. I gotta turn it off and turn it back on. All right. Telescope is off. Never say die. Alright, so let's see. After all that, man, I have been doing so much to get this thing to work right. It just makes me nuts. Yes. Yes. It's actually in a position where it can actually close just fine, but I'm concerned that when we start it back up, it might not, it might go crazy. But you know what? I added a capability so that we can actually have a telescope just by looking at any old star field. It can tell me where it is, and then we can sync it right where it has to go. Okay, and we want to get rid of this. We can get rid of all these things. I may have to tell this computer to reboot, but maybe not. We need that. Okay, micro touch controller. Most especially Path Hub has to go. Why did it do that? There shouldn't have been anything wrong. I mean, it worked just fine. It has been working just fine. The stellarium scope.
Yeah. There's still a bug somewhere.
Yeah. Without a doubt. Okay.
What does Trap 2 mean?
It means that the telescope tried to execute an instruction that it couldn't do, basically. So now what I have to do is turn on the telescope again. But I'm concerned that I might have to reboot the telescope here. Well, we'll find out. It's going to try and do a GPS find, and it won't be able to do it. And let's just see. It might work. It may not. Let's try it. Turn back on to pure power. Okay, telescope. You can see the controller down here is running. So Yeah, okay. That's okay. What it's saying right there is actually good. It means it can allow me to connect. And then I can maneuver the telescope around, find a star field, align it, and then make it go. Can you make it go? Make it go.
Pack leads.
That's right. Okay. All right, let me just move this over here. Let me go to gear. And let's see if it'll connect right. If it doesn't, I'll just shut it off and reboot, and it'll be back in no time. But until then, I'm going to just try to connect it now and hope that I got everything out of memory that was supposed to get out of memory. That may not be a good thing right here. Let's find out. Maybe?
Always something.
I know. Yeah. Apparently. Yeah. There's still something in memory because right now I should be seeing a message that comes up here and it's not coming. So I'm guessing that I don't have what I need. Alright, you know what? Rather than... I gotta reboot. So what I'm gonna do is two things here. I'm gonna turn the telescope back off. And I'm going to get the system back to where it thinks it needs to be. And I think that where it is right now, it's safe to close. I'm actually pretty sure it's safe to close. Right.
Close the roof, you mean?
Yeah, I mean, I have to zero everything back out. So I'm turning off the telescope again.
Okay.
All right. And I am going to... I mean, I didn't have to be honest. I could have actually... actually, I could leave it open. It won't make a big difference, actually. So that's what we'll do. We're gonna just reboot, and it's all solid state, so it should be fast. Not as fast though as without having Starlink. If I had Starlink, that would be good. Okay, we're gonna restart. Okay. Power's off anyway, and that's important.
I watched Venus set behind Pikes Peak tonight.
Did you?
Yep, about 35 minutes ago.
Wow.
Right before you called.
That's cool.
Really pretty. I got into it with someone on Reddit a couple of days ago.
Why you get into it?
He was saying that bright thing in the west after sunset is the planet Jupiter. And I shot him full of holes. I explained it to him, as Khan once said.
Huh. Yes, it's definitely Jupiter. Yeah, right.
He said it'll be up there for a week or so.
Oh, wow.
Actually, being Venus, Venus is finally getting a little altitude.
Yes.
And it's increasing its distance from the sun. So it is moving south with the sun too, but it's finally getting a little higher in the sky. It's going to be up there for the rest of the year.
Yeah. Okay.
Big and bright, you can't miss it.
Yeah. Okay, we're gonna bring these up again. Fresh boot, everything should work. I don't know why it didn't before. And okay, so we got that.
Wow, how'd you get the close up of your controller?
Oh, I just maximized the screen, and I can actually take these all out separately and make them as large as I want.
Oh, very good.
Hey, Marianne, Rob. Marianne's here. Marianne, the telescope screwed up. So we had to reboot the computer. The roof's still open, but that's okay. At least it's pointing in a direction that won't hurt it if I shut the building right now, but I don't want to shut the building right now. I don't want to have to do that. I could if I want to, but I don't want to do that. So now what I'll do is I will... Oh, wait a minute. I may have to. Yep. I'm going to have to shut it because the telescope won't let me turn on the power. Yeah, I can't turn on the power right now. I'd like to turn on the power, but it won't let me. I've got to actually shut the roof.
So this going back to the first step in the whole process?
Yes.
Yeah.
Yeah, that's okay. Okay, well, I'll just shut the roof, that's all.
Isabella, I saw some of your work on YouTube. I'm very impressed. You got skills, girl.
Daryl and I were talking about you, Isabella.
Oh, she shared some of her astrophoto processing with me, and I thought it was great. And
Yeah.
I looked on YouTube, and I found her channel.
Fantastic. Yeah, well, Isabella is very talented, you know.
Animation and commercials and stuff like that.
Yep. Okay.
Impressive.
Wow. I could have modified the program on the fly here to actually make it so I didn't have that fail-safe in there, where I couldn't close the roof without the telescope being in a parked position, but it's okay. Okay, so now I can start from scratch here, so I can say 5 and open it up. It opens up, and then we can turn on the telescope, and it won't be aligned anymore, but I'll have to figure out why it went out of alignment. So now that you'll see the controller over here. Alright, while the controller's coming up, I will start up the capture program so we can see what it sees. Okay, and oh, duh, I gotta tell it which camera we're in. Okay, that's not too exciting.
Night, do.
Can I do? Why
Sounds like Hunter S. Thompson. The drugs are starting to take effect.
What?
Oh, W said, well, y'all, the meds are kicking in, so I'm going to say goodnight.
Okay.
Hunter S. Thompson said something like that, and I think it was Fear and Loathing in Las Vegas.
Okay.
The drugs started to take effect out in the desert. Something of the sort.
Yeah. Okay. I tried to start up my program here and to do the capture, and it didn't work. Let me go see. So if I go here, get out of that, and then go up to cameras, the camera should be listed, and there it is. And if I select it, it should go on. Okay, that might be better. Yeah, that's better. Yeah, so I'm not sure what happened there. I gotta go back and make it RAW 16. Assuming we can actually take pictures. Alright. Okay, now I've gotta bring up the telescope control system and try and do the connection, and it's going to connect. Okay, and I should be able to connect. But before I can connect, it's going to give me this error message, which is good. Yeah. Oh, that's why it was doing that. Okay. All right. I'm going to do something a little different here. I'm going to close that program. All right. And now I'm going to connect the scope and let it do the stuff it needs to do. Okay. And if I go east or west, let's see what happens. There it goes. The telescope's moving, but I gotta figure out which way to take it because I don't know which way it went. I may have to rotate to the east. Because we don't know where we are right now. That's the thing.
Yeah.
I just need a star field.
I just saw the scope start moving. Is that the lag from the Usenet or whatever?
No, I think you're watching YouTube again.
No, I'm on your screen.
You are?
Yes.
Okay. Well, it takes about a second from the time I actually hit the button. Okay. All right, so there we go. So telescope is moving here. Yeah. Okay. That's a lot of poundage moving around, guys. Okay. Now that I have it pointing in the sky, I'm just going to start up SharpCap here. And SharpCap will start now properly as long as I... Alright.
You want to see poundage. I was watching a vid on YouTube a couple of days ago of an observatory over in the United Kingdom.
Yeah.
I forget what it's called, but they have like 6 different domes, old historical telescopes.
Yeah.
It's a 26-inch refractor the guy was showing off.
Wow.
And like you said, the whole floor had to move, to access the telescope at various positions in the sky.
They're just amazing.
And he said that thing weighed 12 tons.
I don't doubt it. That's about right.
Big scopes, 26-inch refractor.
Well, the heaviest part was the mount.
Yeah.
Okay, so now let's do this. Okay, that's better. Okay, so this is the star field we're looking at.
Plate solve.
You got it. I'm going to move this out of the way for now. Okay. Okay, and I have no idea where we're looking in the sky, but I'm going to let the telescope tell me.
At least you're looking up now.
I am looking up. Oh, but there's a problem, and this is this makes sense. You see it's drifting a little bit. It's actually not tracking right now. I have to actually it's going to probably try and take the GPS coordinates and everything. So I'm going to bring up the before I do the plate solve, I'm going to bring up these guys so I can look, and I'm going to pop it out. I'm going to get it out of this mode here, and as soon as I do this, it's going to do a GPS fix. What's it doing? Or is this doing the oh, it might be doing the smart drive initialization, which is fine. If it gets all unaligned, it'll do that. So that's what it's doing now. So let me just bring this up a little bigger.
Did you tell it to do that?
It's part of the initialization when you're not aligned.
Okay.
See, then it stops, and then it'll do some declination. Now it's doing GPS fix. Hopefully it can get it from there. Better get it from there. Okay, it did. So now I can just bring it a little bit south, go a little bit east. Okay, like this. Get us up into a region of space that's, I don't know, kind of interesting. All right, so there we are. And now, from this position, I'm going to do a plate solve, and that's going to give us our right ascension and our declination, the location. I hope. So let's do that now. Okay, so it's captured this frame, and it's going to use it to plate solve. So it's going to try and identify these stars. Having a couple bright stars is kind of good too, because that narrows the field for it somewhat. And if we see that it gives us a green light, it'll say, there we go, we solved. So I'm going to copy those values. Okay, that was fast. And now...
that is too cool.
I know, right? It knows exactly where it is. Now I bring up this little guy right here. And I'm going to just paste in where it says we are. Okay, 1704. Okay, so now what I do is this. I come over here, and I hope this works. 1704, 24. These are the coordinates. See them over there. Up there. And that's the left to right, east to west coordinates. And then the up and down coordinates are 44, 06, 09. That was fast too, wasn't it?
Yeah.
Okay, and now what I say is sync. And if it works, you'll see these numbers change to approximately those numbers. Let's hope it works. Okay, it must have got that exception error that we're used to seeing. If I come over here, it's probably going to say that it did. Yeah, exception occurred. Okay, so what I have to do... Oh, it just becomes a nightmare sometimes. Okay, I have to disconnect. And it won't make the scope move or anything at all like that. And quit. And restart it. And then it may work. As long as I'm just doing things with letting it shut itself down, then I don't have a problem. Actually, I did run. That chart kept running, right? So since it was running, let me make sure that I turned on the cooler. Thermal controls. I don't give up. I'm telling you. Okay, it says it's off. Let me turn it on. Yeah, okay. Cooler's on. Make sure, actually. Yeah, and temperature. Okay. Temperature's 33 Celsius right now, so it's going to drop very quickly. Okay, so now let's, now that we've done this again, let's go back to this, reconnect the gear. All right, and we've done it, and now I'm going to put this in again. 17:04. I don't want to have to do it more than once. This should not have to happen. Oh, I might have to back out of this other menu, which I can do in a moment. 170424 and 4406.
Question?
Yeah.
Is your scope still tracking?
It was, yes, I believe it was.
Okay.
Okay, so now let's see. First things I'm gonna back out of the menu that I'm in. Okay. And okay, so this is kind of where I want to be. So now I have these there. Let me see if I can sync now. If I can't, that's gonna be a problem. Damn it! Why is it doing that? Why is it saying there's an exception? It knows where it is. I'm not sure why it's doing that.
Bummer.
I mean, it does work. It's just like it seems like it's jinky sometimes. Alright, let's try it this way now. See if this works by disconnecting and reconnecting. Alright, let's try this then. We'll replate solve. Okay. Alright. Alright, so now back in here. Bring this up too because I'm going to need it. Okay, so now plate solve again. Wait. It's still not tracking. Or is it?
Looks like it's tracking.
Okay, so now it's tracking. I just saw it moving a little bit, so I wasn't sure what it was doing. Okay, I'll plate solve again. I got some bright stars in there. That's cool. The more bright and dim stars you have, the better it works. I actually tried to plate solve on the Milky Way itself, and it couldn't do it.
This reminds me, I probably mentioned it before, but I did a jigsaw puzzle of the night sky once.
Yeah.
And, well, you talk about maddening, but I finally fixed it.
Yeah. That's a crazy jigsaw puzzle. It goes through the different indexes, and because we were way up north, it was faster, and now we're a little more toward the equator, and it's going to take a little bit longer. So that's what we're waiting for here. Depends where you are. See, look what it's doing now. It's like it stops. It's like it stops tracking sometimes. Oh, look, it found it. Okay, copy. And let's get this in here. I can paste it locally on the machine here if I want to, if I'm doing it out there. Okay. Alright. That's interesting. Look at the declination. It thinks the declination is minus 85. Wow. Okay. But the right ascension is actually reasonably close. Alright, we're going to set this to, instead of 1834, we're going to set it to 1852. 34. And then set the declination to 7. $20. 13. If we can't sync, then, we're just going to have to bag it. But let's see what happens.
Question.
Damn it. What the hell? Why is it doing
Under
this?
declination, you told it 7, 20, 13. Does the north make a difference?
No, because declination would be negative if it was south.
Okay.
I have a minus sign there. And hitting it a second time just causes it again. It just happens over and over. And I don't know what's causing it. Many times I can just quit and restart and it would work fine.
Yeah.
And I don't know why a telescope's like moving around. It shouldn't be doing any movement at all. See what it's doing?
Yes.
I could never use that. That would never work. So if I turn off track and then turn on track, turn it on.
So is the telescope moving, or is that just the rotation of the Earth?
When I have when track's off, it's like the telescope stops tracking. But I noticed a declination shift. It moved up for a second, and that wasn't right. So I don't know what that was. So I'll try syncing again, even though I know that it's probably not going to work. Oh, it did. Oh, now it syncs because you know what I'm going to do? All right. We're going to just... Wait a minute. It synced to 23 hours. What? I didn't say 23 hours. You see that? How'd that get in there?
Don't know.
I didn't type that in, did I?
I didn't think so.
I didn't think so either.
Would you have to plate solve again anyway, since the
I am doing that.
the sky was moving?
Yeah, I'm doing that anyway. Okay, what that's telling me is that the fact that it worked shows that it has got something to do with being within a certain number of degrees of a suspected position. So I have a feeling, because the last position was 4 hours. Now I think we might be able to make this work if I can grab this and get rid of this one. And there we go. Let me copy that. I think I copied it. And paste it in. It still kept the old one because I must have missed it. Well, it was fairly quick. I'll do it again. Look what it did. It just jumped.
Mm-hmm.
Yeah, something's not right. Look what it's doing. It's not tracking right now. Yeah, that's really weird. Hey there, Papa Tom. Just make sure I'm here. Copy. Copy. No, did that copy? Okay, it did something different, so... Alright, well, let's try it. Let's see. Well, the telescope goes haywire here. I have no idea what it's doing. Alright. 1853. 11. I may have to just go in like 15-degree increments to get it to reach it. And then 720, 40.
Declination was still close.
Yeah, it is. Finally. Because it did actually, look what the telescope's doing. Like, yeehaw. Alright, let's see if this will work now. Sync. Okay. So that's synced. Alright. So, now, let me go back to my placements. Let me place this over here. As I told you, I don't give up. I hate that we're squandering the time without the moon, though. That's bothersome. Okay, I'll leave that there for now. And this can go away for now. Actually, I wanted to make it minimized anyway. Okay. Now let me get my... I'm going to minimize this for a sec, because I want to look at the scope for a minute. Alright. Alright, couple things I got to do. Number one, I have to do something right now before I do this. Now that we're synced, the telescope kind of knows where it is. So I'm going to bring it down to a position where I want to be able to, say, park it if we're to say we're done for the night. And that park position depends on its alignment. If it's not aligned properly, it won't park properly. So I'm resetting this parked position. And that's just going to be a little more down. That's good, actually. And then I can go into the menus over there on the right. I can go up one, go to setup, go into the setup, and drop down to telescope, enter the telescope section, and keep going down until I see park position. Mount upper and lower limits, and then park position. So there's the park position. I hit enter on that, and enter again. Use the current position. Boom. Alright. So now the park position is set. That all said, now we can go back out and try something. Try this again. See, it only took us about 20 minutes to get this back, right? I don't know how long, actually. How long are we futzing around here?
I'm not sure offhand.
Probably too much time.
Maybe a half hour.
That's probably true.
I remember when I mentioned seeing Venus set tonight, I think it was 35 minutes after the hour of my time.
Okay. You could be right. Alright, so let's put the telescope back over here. Alright, we'll bring this up here, because we're always going to have it behind that. And then we'll take this guy out, and we'll set out of this frame, and I moved it into a separate standalone window.
Oh.
Okay, let me just get this like this. Well, what you're getting to see is all the setup I do ahead of time before you guys come on board. Okay. And this will go over here. I can't wait to have Starlink, man. It's going to be so fast. So much faster. And now that we're aligned, that I think that what we want to do, now that we're aligned, is I want to be able to see, we're seeing stars because even though the telescope's pointing partially at the building, it's actually also being able to capture stars. So I want to just go up here and just make sure the telescope is not doing some weird stuff and movements that it shouldn't. Okay, so we have raw 16. See, it just did. What's going on here? That should not be happening. I should, like, if I capture a 10-second, let me just say 10-second photo. All right. There should be nothing but dots. You shouldn't see streaks. Okay. No streaks, which is good. Okay, let's doing it again. All right. Okay, you know what? One possibility is that the screen is too big and it's actually an effect of using the mouse wheel, because I'm doing this with the mouse wheel. So I think that was the vertical jump that I was seeing, which is very good. It's a good thing that it's that and nothing else. All right. Confirmation of where we are. It says we're at 1853.03 minus 2852.55. If I do another plate solve, it should say those numbers should be pretty close to what it says.
Right.
So let me get those. Let me actually open up a notepad locally here. Oh, darn it. Copy, come on, get it. All right, I got it. So, notepad. Okay. And let me just see. It says 1850.28. We're at 1853.03. And minus 28.54. We're pretty close. This is good. Okay. So the telescope is definitely aligned. Finally. We did the equivalent of one star alignment, as it's called. Okay. I don't know why it happened, but it did. So what we're going to do now is I'm going to bring up the planetarium side of things, and not this guy. Wait a minute. Yes, I can start from here. Desktop. And Maudlin Hain Observatory. The official name of the observatory, by the way, guys, is the Maudlin Hain Observatory. It's named for Marianne Robb, and it's named for the owners of the property who granted me the rights to put it there. So, here she is. Marianne, I think I can close the roof. And I'm not giving up. You know, I was able to troubleshoot this from all the way out here, and I think that's a pretty good. I'm pretty glad to be able to have done that. So now what I'll try and do is actually do some astronomy. Let's do medium icons. There we go. All right, so let's bring up the stellarium thing again. It should just connect and bring up stellarium. There's something about telling it to do a go-to that just for whatever reason did not work. So I'm just going to steer the telescope there. When I get out there, I will troubleshoot it. I'm going out there in a couple weeks, actually. I have to speak at Pine Bush in New York at the conference there. Then I have to speak at the UFO Congress out in Phoenix. And then when I come, when I'm there, I'm actually going to go out to the desert to the observatory. And then first thing I'll do is probably hug the telescope. I missed you, honey. And then I will do any fixes that I have to do.
Question:
Sure.
Is Stellarium in agreement with?
I'm about to find out. I'm going to click on that. That gives me the... it says I'm at 1851. Yeah, minus 28. Yeah, we're in agreement. There's a plus or minus, but yes, it's in agreement. So if we...
a couple of arc minutes, looks like.
What's that?
Within a couple of arc minutes, it looks like.
Yeah. Not bad for an emergency situation tonight. So what I'm going to do is try to go back and locate the object. Well, first of all, first thing I have to do, we are got to make sure, I got to find out where the moon is here. Oh, it's rising. Darn it all. So it's putting a pretty big glow in the sky. We lost all of our time. Darn it all. But you know what? In a never say die thing, we may not be able to capture nebulae in the same way, but there's some really cool clusters out here. And I think maybe that's one to check out. I don't know if I should try this. Should I try to tell it to go to the wild duck cluster and just do a go to? It could screw it up all over again.
Maybe start out with small moves.
Yeah. I don't know why it did what it did. I'm a little spooked. Here's what I'm going to do. I'm just going to steer to it. I will just steer to it directly. And just go there that way.
That was your solution before, wasn't it?
It was.
Yeah.
Yes, it was. And
So
I'm
manually driving to the objects?
Yeah. I mean, that's actually kind of fun because people get to watch it drive through the sky, but I like automatically allowing it to go because that's, of course, the capability the telescope has. So I should be able to do that. Okay, so this, now we should have it in our field of view fairly close. It's the wild duck cluster. I don't see it yet. Oh, wait a minute. Okay, so I see a globular cluster down there. We probably just need to go up some more. Unless it's over to the left a little more. We'll see. Okay, let me, I would say that's it.
There it is right there.
Yeah. So, I'm going to center it. Alright, and then what I'm going to do is, first of all, actually what I'm going to do is to set the speed down to something. Where'd it go? I threw it out. I think I tossed it out. Why did it just disappear on me? Oh, look at the satellite right there. That's a tumbler.
Mm-hmm.
Yeah. Okay. Let's drop down to a lower speed here. And now I can actually do this a little better. So I see you guys, you're already seeing satellites and stuff. Alright, let's bring this up a little more. See, we can still use the telescope. We can still do all this. No, that's Measure 11. That's beautiful. Now, if it's clear tomorrow, we'll be able to spend more time without the moon in the sky and do some stuff that I wanted to do. I wanted to do the Iris Nebula, I wanted to do the Elephant's Trunk, and I wanted to do the Cocoon Nebula tonight. But it had other plans. Actually, how many seconds? This is actually this has been 10 seconds all along. So that explains why it was moving, because it was a delay, because I was doing a 10-second photo. If I was doing a 1-second photo, all right, this would be very different looking, okay, because I'd be doing this, all right, and then I would do a super enhancement to bring that all in so you'd actually see it like that, okay, and then I could actually move it over and you see the actions like immediately, because you know I'm moving it around dynamically. Look how many stars are there. That's that Messier 11 right there is a bright cluster of young stars, and it's actually right near one of the Sagittarius star clouds, and you can actually see that star cloud right there to the right. Marianne. Hey, get the telescope working. Police order. You're not a cop anymore. You can't order me, biatch. You're going to bed. You're teaching in the morning. That's right. Marianne's going to be teaching at the MUFON Symposium. MUFON doesn't ask me to speak at the symposiums anymore. I don't know why. I think, I don't know what it is, you know. But I do certainly talk everywhere else, so I don't get it. Anyway, let's get a nice shot of this just to give you an idea of how this looks. And before we actually lose our night totally, I'll do a 12-second shot of this guy, and we're going to live stack it. Okay. So the live stack window comes up. We have it automatically sized to that window right now. Hey, David Schmidt. Okay, and what I'm going to do is set some boundary limits here. That's obviously, you can see, this is to show you, you can see all these dark nebulae that are out here in this processing here. I'm going to eliminate that, eliminate this, and come back and get rid of our camera process that we had there for our other histogram, and then we'll bring it to more reasonable view. But I think we can do this guy. No, I don't like that. We're going to see progressively bluer and bluer imagery when the moon comes up. Okay, so that's more like it. And then you can see that the dark nebulae are actually in here. So that's pretty cool. And I can change the gain a little bit. We are live stacking, and we've stacked 6 frames so far. But I could increase the gain. Okay, I made it 415. And what I'll do is I'm going to clear the stack and start all over again. What? That's such a pretty picture. Yeah, I know. But don't worry, we'll get more. We have an observatory in the desert, man. Well, now we can get more. Now look at that. Look at this. Look at those beautiful clouds of dark dust. You know? Yeah.
David Schmidt, I think the wild turkey clusters in Tennessee.
That's funny. That's funny. Alright, this is gonna... Okay, this yellow line, just so you guys know, this yellow line here, this yellow line is our path through the data. This is the data, okay? Okay, and it's 3 colors, red, green, and blue. And we're getting the response of each of those sets of pixels in the camera, the red, green, and blue. And they more or less line up for the most part. And this right here represents the slice through the data that we're using. That's what's giving us this picture right there. And you might say, well, why not just get that too up there? and then we see a lot more, right? Well, I'll show you what happens when we do that. Okay, if we bring that up there, okay, unfortunately, you got a lot of white up there too. A lot of overexposed stuff, see? So we can't really do that, unfortunately. So we have to pull it back some. Okay.
Mark, excuse me a moment, please.
Sure thing.
Be right back.
There's some beautiful red stars right here. These orange guys right here. Those are really pretty. Really nice. Yeah. And if you go to my Facebook page, Mark D'Antonio's Facebook page, or you go to SkyTour LiveStream's Facebook group, pinned posts at the top have the link to the live imagery here. Okay, so all the imagery that's showing up right here is now being shipped up to the cloud as we speak, and it will be there in just a few minutes. I actually saw a picture showing up there 30 seconds after I took them last time, but it depends on the speed, you know. If you wait an hour, they're all going to be there, you know. Yeah. Well, thank you guys for sitting through that little terrifying ordeal a little while ago. I couldn't actually couldn't solve it right away. I was trying to go through the steps in my head. And it may still not be solved. I may have to do more, and that's fine. I don't mind. Anything for you guys, you know. All right, let's move this over a little bit back the other way. Okay. So once again, for those of you watching for one of the first times, this side over here, this is the camera controls with the thermal controls for the camera, the exposure, and so forth. This is the exposure. We're doing 12-second shots, and at a gain of 415. That's like the ISO, the sensitivity. The higher the number, the more sensitive the sensor. This is the telescope control over here, and we're doing a live stack right now, so you actually see the live stacking image right here coming in. We can do all kinds of things at this point. We can actually add, for instance, we can add sharpening and make it look a little bit sharper on the fly. Okay, and you'll see that show up there. And now look at that. Now you see it much sharper. All right, so that's kind of cool to do. And it's nice, you know. And these are actually very, very good approximation of the colors right there. So it's really nice. It's toward heading toward the you know, one of the star clouds in the Milky Way, and the star clouds tend to be older stars heading toward the center. This is not quite near the center, but it's off center. But we're actually seeing reddened, you know, more red stars because of the fact that there's a lot of black dust that's in the way. It's like soot if you think about it that way. It's like soot, you know. Okay, we did 24 frames. I think that's enough. Here, this is enough for you guys to play with. Look at that beautiful dark clouds up there, those dark nebulae there. I'm glad we could do that. And then if I hit save, we're going to save the stack. The stack is out there, and then I'm also going to save it just as you see it here. So that's available as well. Okay. All right. Now, let's go back and change our exposure back to 1 second, and then do the ultra enhance to be able to see this thing in real time. Okay, so there's the 1 second shot coming up, and I'm going to clear the stack. All right, and get out of this. That's not quite the 1 second stack. That's the 1 second stack. And then we actually do the ultra enhance, which is not meant to be a realistic view, but is a basically like a finder, lets you see what's going on, you know, quite nicely. That's pretty nice. And you can see the pixels changing a little bit too, because this is a live view. Right, so now, even though the moon's up, gosh, I probably shouldn't do this. I don't know, maybe I should. Okay. I'm going to try, even though the moon's up, I'm gonna try to get to another object here that I think would be cool. Let's just bring in our constellation lines so you can see them. This guy right here is that little cluster, but I gotta zoom in more to find the other thing that I'm really looking for, which is this guy. Okay. Now normally I would just say go to this, and I wouldn't, it would just go to it, I'm feeling gun shy about this right now. But I guess I could, but I'm probably not gonna. I'm probably gonna just, it's basically just, up the lines and over. I can do this. So I'll do it manually for now. The only thing I'm gonna do though is I'm going to change the speed back to the maximum speed so I can get up there quickly. And this is the right ascension declination line, so it's gonna follow the lines pretty roughly. All right, so let's go. Okay, and then we're gonna head to the east a little bit.
I've wondered before.
What's that?
When you lose control of the telescope, like tonight, if there is like a program conflict or something, with a Stellarium talking to APT or talking to the others are camera control. If it's confusing the drive system.
I've watched that myself, and I don't mind steering to objects. I really don't. That's fine with me. All right. I just don't like the fact that I have to. I shouldn't have to steer to objects. But
well, sure.
But the thing that's important here is that plate solving has solved our issue of not knowing where we are. And you saw how fast we were able to come back to life here, basically. And that's very, very good. I know you probably want to see this starry screen, guys. I'm sorry. Let me do this for you. Maybe this will help. Yeah, because that's what we're looking for right there. Okay. That is the Dumbbell Nebula. And we're going to actually take a few images of that. Okay. Alright, so here's what we'll do now. This guy, we're actually going to, first of all, I'm going to undo this super enhancement, and I'm going to, you can basically see it just right there. You can kind of barely see it right there. Daryl's called it the Apple Core Nebula. Some people look at it as an hourglass. I look at it as a bipolar planetary nebula. Okay. Okay, we're doing 25 seconds now on this guy, and we're going to live stack it at the same time. Okay. So here we go. And we'll actually throw the unsharp mask into during this period and see what happens. We can always undo it. And in fact, actually, first things first, I gotta clear this. This is that measure 11. It's still in there in the buffer. But again, thanks for sitting through this. Sitting through this crap that we had to deal with. Yeah. So 25 seconds, and the reason I'm doing 25 seconds is for a very important reason. I want you to see the extents of the nebula here. Let's see if this makes it a little better. Yeah. Let's see if this makes it a little better. Yeah, it's a little more enhanced, but you notice the sensitivity of this camera is such that it's actually overexposing the nebula. Let me drop this back a little bit. Okay, I don't know what it is you're saying, but every one of your messages are being held by mods. I don't know why. I'm not doing it. The moderators are. So I'm not sure what it is that you're doing over there. But hey, we're just having a fun astronomy time. It's fun. Punctuated by moments of sheer terror. Yeah. Yeah. Now, here's the thing that I'm going to show you, by the way. When you look at this object, okay, we have 4 frames stacked right now. And if we zoom in, okay, you can see that as we zoom in and just go way in here, you notice, one of the things you notice is that if we go into the starry fields here, and by the way, I've been talking to the people that made the special equipment for the telescope, because these star images are not right, and they've given me some options and things to fix it. So I'll have that fixed when I go out there. These are gonna be pinpoints in another week and a half. But you'll notice you don't see any of this graininess here. There's usually graininess in the frames that we take here, but not here. And the reason is because when you stack, that graininess is averaged out. So you can see in between my fingers, right? Okay, but if you actually were to put more fingers in and cross them around, it might be just a blank set of fingers without any holes in them. You wouldn't be able to see between them. If they lined up exactly like this, that could be a problem. But they're moving a little bit left or right, okay, and they're being shimmied. And that shimmy actually gets rid of most of the noise, and that's what stacking is doing for us in this process as well. Is when we do this. Again, this is the Dumbbell Nebula. This is at right here it's 58% size. Give you an idea just how big the field of view is, or the camera range, I should say. I'm going to go to 100%. So this is the size of the actual frame right here. So there it is. Okay, and it goes up quite a ways. Okay, and it goes down quite a ways. Okay, so we actually have a very, very powerful system here. And the nice thing is, even though I'm moving this around, it's still being stacked. Okay, even now, it's still being aligned and stacked. They're being stacked on top of each other. Okay, we've done it with 8 frames so far, and it doesn't matter what I do to it here, because the camera is aligning them in the computer. It's aligning all of the imagery and getting them perfectly aligned, no matter what. So I think that's pretty cool. So anyway, so that's cool. And
we have a troll in the room.
Yeah, I saw that. Hey, you know what? You're somebody when you start getting trolls.
I guess.
Yeah. Yeah, the more people find out about what I do, they tend to, the trolls do tend to come out. And speaking of that, if you guys have Discovery Plus, you can check out the documentary that we did out in the Hudson Valley. We did Alien Invasion. It's called Alien Invasion Hudson Valley. And Ben Hansen, a good friend of mine, and Melissa Tittle, another good friend, and we were a triumvirate of investigators, and we went to the Hudson Valley and we looked at there were 3,000 cases there just in the last decade alone of people that have had things happen to them there. And one thing's for sure, these people are terrified, for whatever reason, and they all have separate experiences that they've never told each other until we came along and said, listen, you can trust us because we are science folks. We want to know what's going on. We want to help you. And we did find some answers for folks. It's in the documentary in some of the cases. In some other cases, we need more time. We need more stuff. But it's actually, it turned out better than any of us on the team thought it would. The people that edited it, I mean, again, I was asked to be part of it by a production company. And I was like leery of doing that thing because, like, what are they going to turn me into? Like some, weirdo? I'm already a weirdo. But it turned out that they did a good job. And it was actually a very impressive production that they put together. I was very happy. They let me use scientific equipment that I wanted to. They rented very, very expensive cameras that if you use them properly, they have to be liquid nitrogen cooled, okay, to be able to detect things that are outside the visible spectrum as well as the visible spectrum, okay. Cameras, in general, can see a little bit into the ultraviolet at one end and a little bit into the infrared where we can't see with our eyes. But if you actually look at the visible spectrum and then go down to the infrared, there's a huge swath of the infrared. It goes out to the radio frequencies and beyond, okay, to much longer frequencies, microwaves actually before the radio. And then on the other end you have ultraviolet, which goes to cosmic rays, gamma rays, X-rays. Down that end, higher frequencies. And I think I think the best part of this is that the camera that particular camera was able to see all of this at once. So when you looked at a person's face, you didn't see just the face, you saw the infrared energy in their face as well as ultraviolet, which really shows freckles and other things on their face. So it was a really interesting sensor in this camera that we used. And that part of it was just a minor part of the show. But we did get to use a lot of the equipment that we really wanted to. I flew the infrared FLIR drone that I have, the forward-looking infrared system I've got mounted on one of my drones, and we used that for the production. Saw some very cool stuff. Had handheld. In fact, actually, this right here is a handheld infrared system, and I was able to use that to actually see that we actually had somebody in the woods following us at one point when we were doing our investigation. So it's pretty crazy. So while I've been talking, we're up to 17 frames that we've stacked. See over here? Yeah, 17 frames.
Mark, David Schmidt makes an interesting point.
Sure.
He says, amazing how the colors, gases separate but still stay within the cloud. How does that happen? I mean, when we look at the dumbbell there, we see the pink at the top left and bottom right.
Yes.
And the blue-green, more scattered around.
Okay.
Is it that as the star died that it released the hydrogen or the neon first and then the oxygen, or?
Yeah, precisely. And so what happens is, most of the materials that you're seeing here in this planetary nebula could very well have actually been in the star when it was formed. Some of it was made, okay, and some of it was dredged up in the process called dredging, okay, within a star. But the thing is, a lot of it could have been there before, but the thing that happens is, as the star expands into a red giant, okay, and the star that did it is actually right there. You can barely see it in this image because we kind of overexposed it. All right, and I'm going to stop this right now and pause this frame, save it, and do the same thing I did, because I'm going to finish that explanation for you. And that dredge up process will bring up stuff from near the core and get it out where it might make its way to the outer parts of the star during this process. And what happens is, as the star, runs out of hydrogen fuel, it begins to shrink. As it shrinks, some of the hydrogen in the outer envelope that is hot in plasma but isn't hot enough to fuse gets toward the area in the fusion zone, and it begins to fuse. And then helium does the same thing, and we start to get the star rapidly expanding again and then shrinking as those fuels deplete. And so it goes like this, and it sort of bounces up and down. Every time it does that, it pushes off a little layer of stuff that never comes back. But why, you'd say, can a star lose some outer layers like that? The reason is because the star is so big. The red giant has grown to such proportions that the outer layers are just a stone's throw from being gravitationally unbound from the star. So that's what happens there. Now, that said, when we look at a nebula like this one, okay, as the star sloughs off those outer layers like we were talking about, well, many of those layers are oxygen, which is that turquoise coloring you see there, and some is hydrogen, which is that reddish you see there, and some neon, which can also account for some of the red. And I think that part of this is from that process that you're seeing that, okay, from the dredge up and final sloughing off of the layers. So that said, that explains how these things look, but it doesn't explain the shape. See, it looks like an hourglass. If a star is round, shouldn't it be just making big round spheres of concentric shells of stuff? You'd think it would. However, there's another variable here, and that is that these stars, many of these stars, are actually rotating faster. So when they do slough this stuff off, the speed at the equator of the star is much higher than the speed at the poles. So maybe that accounts for what we're seeing here and here. Maybe the star was rotating this way, like that. All right.
So we might be seeing a donut from the side.
In a sense, we could be, yeah. So this right here could be going this way, and if it's going that way, coming towards like that, then when the layers went out, they tend to go that way more than they would this way, because this direction here is a lower velocity because it's at the poles. So that has brought us. Again, because of the poles on the star, north and south, that brought us to the term bipolar. It doesn't mean these are very poorly behaved stars. It just means that they're very much shaped in this way because of the nature of potentially of their spin rates early on before this happened. There's other bipolar nebulae that look very different from this too. So those mechanisms by which that happened is another thing we don't really know.
I have another question.
Sure.
I mentioned this when we looked at the dumbbell the other night.
Yeah.
There's sort of the brightest portion of the nebula.
Yes,
there at about 4 o'clock, right there.
Yeah.
It looked yellow the other night. It looks white tonight.
That's because it's overexposed.
Before the, I'm sorry.
It's because it's overexposed.
Well, yeah, but before the last few frames loaded, it was there's a red portion to the outer part of that.
Yes.
And it was brighter red before it overexposed or whatever. What do you think is happening right there?
That's an interesting feature.
The red chunk was brighter, plus the yellow or the white chunk was brighter also, and you can see it there still too.
And that's why I dropped the exposure to 5 seconds so you can see it. Let me see if this helps. Oh, there's satellite just went zipping through there. Okay, there's a satellite trail. Okay. Let me just undo that now. Yeah, this. Let's take a look at that. Actually, that's a really good point. So when you look at this, right, okay, you can see right here, you can see that little star. That's actually a white dwarf star that's about the size of our planet Earth. But it's so hot that we can see it from this distance away, right? And it's very clear right there. Now, the hourglass shape we discussed as possibly the rotation. However, this little tongue of material that Daryl's talking about right here, that's pretty cool. And you know what might cause that? We don't know the interstellar medium at that point. It could be dense there. There could be a knot of material there, and material from the star could have impacted it and gotten snowplowed by it, or slowed down or sped up. And so we don't really know why it's shaped the way it is. It could have also been a non-homogeneous manner in which the star pushed off its outer layers. Again, when a star is in its heyday, it's actually making a cavity around itself. It's emptying out the area around itself, especially the very hot stars. These are not. These are like sun-like stars right here. Okay, the sun-like stars, those guys will just sit there and percolate for a while, just like our sun, and then they puff up, blow off the outer layers like we saw, and then eventually just shrink back down to a white dwarf. They can't go down smaller to a neutron star, or smaller still and become a black hole. So this is what we get. Now, what's interesting about these guys, well, everything's interesting about them, but the thing that's really fascinating is that when we look at how these nebulae form, we have to remember that the interstellar medium into which this material is going isn't all the same. It's not a vacuum. It's not all empty. There's stuff there. Remember I showed you that picture of Messier 11, the cluster, and you saw all those dark clouds around it, okay, amid the star clouds? That's happening everywhere, and there's all kinds of dark dust everywhere. And that matter is something that an expanding nebula like this one can collide with and change its shape. And it might look very different, from that, through that process. So I'm going to say that I would guess that there's probably something in this region that altered the shape of this material coming out of that star when it came off the star. Keep in mind that the star is very far, that the white dwarf is very far from this nebula. Okay, it's like 2 light years further. About a light year inside the nebula. So if you think about it, that's a fairly long distance. There's plenty of room for the interstellar medium in between to be chunky with other stuff and debris. So that's probably what's going on there. That's a guess, but we know the interstellar medium is not the same everywhere. We know that it has all kinds of density knots. Okay, I mean, just look at what Voyager found when it left the solar system. Okay, Voyager started hearing plasma from interstellar space, and it had knots in it. It would hear like, and those are knots in the plasma that it's passing through. It's not all the same. It's knotted up and bunched up in places, and most likely the expanding star has encountered that too. I hope that's not over-explaining. Was it over-explaining? It was over-explaining, I'm sorry. When Daryl doesn't say anything, it's over-explaining. But you know what? You asked the question, so there.
Yeah.
Yeah, I'm never going to do that again.
I asked for it and I got it. Well, I don't know, looking at that, trying to visualize it in 3 dimensions, I mean, yeah, maybe it's just a blob that the star put out at some point when it was coming apart. It looks more energetic. Maybe it's just a thicker part.
Well, you're seeing it in 3 dimensions
maybe
too, remember?
Maybe it's pointing toward us more than we see on the other side. Maybe it's tipped back at the top.
It could be. Yeah.
do white dwarfs beam or jet rather like pulsars or neutron stars do?
Not as far as I know. I mean, white dwarfs are pretty well. They can do some pretty violent things. Okay, let's be clear. But this particular star system that is here is a singular star. It's not a binary system. Usually, a white dwarf in a binary system. Okay, the reason a white dwarf is a white dwarf is because it hasn't achieved 1.44 solar masses in its core.
Yeah.
Okay, if it's greater than that, then a couple things can happen. You can get a supernova explosion of that star blowing up, and we call it being disrupted. I mean, why don't you say explode cataclysmically rather than disrupted? Okay, but that's what they say. But the star also can basically flare that stuff off in a flash of immediate start. It can immediately start burning, fusing this hydrogen on the surface, and cause this amazing flash of fusion that takes place, and that's a nova, not a supernova. See, and it requires a binary star system for that. But
well, that's what happened with what was it, RS Ophiuchi just recently?
Yes. Right, the novae, okay, novas, supernovas, kilonovas. Yeah, it's like, whack-a-mole of the universe, man. Those are just crazy energy release, Yeah. So anyway, let me just go check something here. Let me bring up our system. Let me find out how high the moon is. I like this song. Okay. Let's go. You know what? While we're here, actually, instead of doing this, see, there's the Andromeda Galaxy. We're not going to be able to... It's too low. Not easy. It's easy to get to, but not... It's too low to see it well. So while we're here, I actually think we want to just check the Eastern Veil. Alright, so we're going to go to the Eastern Veil. Alright, I want to do this now. Okay, hold on.
That pic you showed me today looked like it was, I think you said it was the Central Veil?
Yes.
Plus you can see the top part of the Witch's Room.
That's right, down below. Yep, it was there.
Like if you bumped that up, or I guess you would have, if you had gone down just a little bit to raise the Witch's Room higher, you could have caught maybe all of it. It's in the same exposure.
But I would have lost the top of the Central Veil. I tried it.
Oh.
That's okay. Okay, let's go here first, and let's go to auto mode here. Autobots. There we go. So there's the full frame view. All right, and we should be on a second. I'll confirm that. Okay, 1,000 milliseconds, which is 1 second. And I'm going to change. No, I'm going to leave it at 415. Okay, and I'll even leave this in there so you can see this thing come in. Now I'm going to go back here, and we're going to head up to the Veil. All right. Next thing I'm going to do is set my speed. Let me just do this. Set my speed to 7, not 9. That's maxed. This is 1.5 degrees per second, I believe. Okay, so what I'm going to do is I'm going to head to the east. Okay. You can watch the telescope in the window over my head. Okay, I went.
Is what Stellarium is calling filaments, is that also part of the veil?
Yeah. And now we're going to come up.
Or would that be the Witch's Room?
Well, the filamentary nebula is what they call the Witch's Brew.
Yes.
Yeah. Stellarium is a free product, guys, and it can even control your telescope or apparently destroy it. We have to be careful. I'll figure this out. This is all par for the course, you know? It's all part of the process of figuring this stuff out. Alright, slow this down a little bit.
At least you don't have to use Pony Express or Morse code anymore.
No way. Yeah. Alright, so if I go up this way...
21st century problem.
Yeah. Alright, so from here, I'm going to come down a little bit and then just sweep across the entire nebula so you can see what we're looking at here. We just saw a star that died a natural slow death, which was the Dumbbell Nebula. That's a planetary nebula. That's a rather quiescent or calm death to a star. This one here is the exact opposite. It's actually the death of a star from a major explosion, a cataclysmic explosion. And that's, of course, a supernova. And you'll see it come into view here. I'm going to actually have it coming up on the screen here, and you'll see it. And as I start to approach it and get into it, I'll get rid of the stellarium screen and you'll be able to see it all happening. So first things first, let me go down to slower speed here. This will be 1/4 of a degree per second. And now let's head east. And you'll see it coming in here pretty soon. Here it is. Alright, so that is a beautiful image. That's the western veil. Is the western side of a supernova explosion. The supernova occurred over there. Okay, so basically over here somewhere is where the supernova exploded, in this region right here, and then the stuff expanded outward. And this is what we're looking at right there on that in the western side. That's the expanding cloud, or I should say gas. And you remember when I told you before that the bigger, more massive stars, when they are fusing hydrogen into helium normally and other things, they actually form a cavity around themselves that's almost empty of stuff. It pushes stuff away from them with their strong stellar winds. That's what this particular system did as well. That's what they all do. And then as the star aged and as it went supernova eventually, that material moving out at a high rate of speed eventually caught up with the edge of that cavity that was created by the star. And when it hit that edge of that cavity, it slowed down. And when it was slowed down by the stuff that was at the edge, in other words, the interstellar medium, the stuff in the interstellar medium, then it compressed the gas, made it very hot, and caused it to glow like this. It glows green, it glows red, as you can see here. Then you see a very filamentary section here in the middle. This is the central part of this supernova remnant. And then continuing on over to the eastern side, all right, is the other side of this entire nebula, which I think is also really kind of fascinating. All right, and you'll see it here in a sec.
It's big.
It's very big.
Now, the whole veil is several times the size of the moon, I believe.
Yeah, it is.
Several degrees across.
Yeah.
There it is.
Yeah. So as we come up, so this is the other side of it. Now, it's about 100 light years across, and it's about 14 to 1,500 light years away. And this star exploded about 8,000 years ago. Okay? So here we see one side of the veil. Here's that central part that you see right here. And then the other part is way over on the right. You can't see it in the same view here because it's not a large enough field, and this is a big field for a telescope. Okay? So that's pretty cool. Now, let's center up. Let's center up the eastern veil. Let's bring it on in. Okay. And then what we'll do is we'll actually we'll do some stacks of this, because I want you to have it, and you can then head up and grab it. Okay, so we'll make this a oh man, let's go 25 seconds on this. Now the moon is out, okay, so this may not be the best, job, but I am using a special filter to counteract the moon as well. So we'll see what we can do here.
Mark Nichanen Comsanta asks how far away from Earth. You said 1,000 light years?
This is not this. Oh yeah. Okay.
Well, yeah, the veil.
Yeah, the veil is about 14 to 1,500 light years away.
Okay.
Yeah. Yeah, I got you. You can't align because there's nothing to align. Oh, did I have the wrong thing here? Oh, it's trying to do it in milliseconds. Well, no wonder it can't align. Alright, this is 25 seconds. I thought I hit the S. Okay. Alright. Now, I'm going to clear the stack again. And down here, you see there's no data. So our line of process line is showing that it's going through nothing. But as soon as the first image comes in, you'll see something here, and you'll actually see this going through the data. And that will give us the image that you're about to see. Yeah. And
Donald Kunzer asks, has the original star been ID'd? Is there anything left of it?
Yeah, I think there's a remnant. We can't see it with our equipment, but there is a veil remnant that's there, stellar remnant. Honestly, I've never actually looked for it, to be honest with you. So that'd be something to actually see if we can just see it as a pulsar or a neutron star or a black hole. We won't see the black hole, Alright, let me just take back some of these previous additions here. Okay, so what's happening here is the moonlight is casting a blue glow, and that's what's happening here. I'm gonna that's gonna be too blue. But this is what happens with the moon, and so we have to try to counter the blue glow of the moon by trying to correct the color, which is what I'm doing here. And so this, what do you think? I mean, this is happening right before your eyes. This is so cool. This is the coolest thing, man. That actually looks pretty good for a full moon, Daryl.
Mm-hmm.
Let's just we're gonna pin the stack here, which means it will set it up, and then it'll get out of the way, and we'll be able to see it bigger. Isn't that wild? That is such a beautiful render. Look at that. Now, we talked about this before, but check it out. We're seeing reds and greens. Again, those are materials that are commonly made in the stars, and they're also, stars are made with them in their atmospheres when they're made with them. And some of these atoms that are in this have probably never undergone fusion ever. They're just in the atmosphere of the star. And when they're in the atmosphere of the star, they're very hot. They're made so hot that the electrons are driven off in ionization, leaving plasma behind, which is just protons running around all alone and electrons running around all alone. Our sun does this too. But the heavier stars and more massive stars like this, also doing the same thing, big time. But I actually really like this shot, so I'm gonna let this go. But here's the thing that's interesting. Okay, again, that cavity we talked about. You notice how it's got this gentle curve to it. It's got that gentle curve because of the fact that the center of this is out here somewhere. Okay, and it's a sphere, remember, because it came out in all directions. So some of it's coming toward us, some of it's going away from us, some of it's coming kind of on an angle perspective. So when we look at this remnant right here, this remnant right there on the screen, it's probably kind of got a shape to it like this, but we can't really tell. It could be a very wide shape, all right, and be a huge shell chunk, but we only see this filament, so we don't know that some of the parts of it could be farther away from others and be kind of on edge to us. That's what's kind of cool. So it could be like this, you know, and you can't tell them. You can tell because you know how big a hand is, that this hand over here is farther away than this hand, okay? But to see a nebula like that, where these are just gases that are glowing, you can't tell whether those are together or far behind each other or even separated by some distance. They may very well be. If we went around this in 3 dimensions, we might be surprised to see that broke out maybe into, say, this. We don't know. It could break out into multiple pieces for all we know. But this, again, as this material from the star was blown out millions of miles an hour, basically, and as it started to reach that cavity, the edge of the cavity where the rest of the interstellar medium started, okay, where that star originally had, its stellar winds had pushed this stuff out, when it got out there, this material then was forced to slow down. It was like hitting a wall, and that wall heated it up very hot, and any atoms that were here, the atoms had their electrons driven off, and the electrons would then recombine with the atoms spontaneously and giving off light when they do. Hydrogen atoms have a reddish glow when they are recombining. Oxygen atoms have this turquoisey teal glow when they recombine. Either way, it is a stunning outcome for all of us to enjoy. And I think that's just beautiful. Look at that, Daryl.
Yep.
Jeez. And it's a full moon night. Nearly. It's a little less. But look at that. So every one of these little tendrils, every one of those is a result of a shock front where the material is hitting a different density of the interstellar medium. And again, the interstellar medium is not even everywhere. It's got all kinds of, bumpy areas and so forth where there's higher and lower density stuff. And this is what you get, as Carl Sagan would say, we are made of star stuff. And he coined that phrase. And the star stuff is right there in front of you. And this is it. This is star stuff right here. All that. And it's just beautiful, just sitting there. And it really makes for a beautiful image. And it's expanding, by the way. So in a few 100,000 years, it'll be bigger, and maybe won't be as bright. Maybe the material that's glowing now will not be glowing anymore. Vera says it's a rainbow of color. You're absolutely right. It is a rainbow of color, but the colors are very specific, Vera, and the colors are specific to the atoms that are causing them. So that's unfortunately what we're dealing with here. Now we've stacked a number of images. Let's see how far we've gone. We've actually stacked 16 images here. So 16 images. So Isabella, get ready, because she's been really doing well on the image processing. So I process them and put them up there, and she processes them and she also posts. So check out her versions as well. She does a really nice job. I don't know if she's still out there. She may be. But that's Isabella Melamed. She's from Sofia, Bulgaria. Vera, you're from Brazil, right? I think you're from Brazil, if I'm not mistaken. I think you told me that.
We have several guests from Southeast Asia, I guess. I don't want to insult them by mistaking where they might be from, but the names sound vaguely Thai.
Okay. Well, they could also be Indonesian.
Could be.
Yeah.
So Pardon me, folks, if I made a mistake in where you might be from.
It's all right. Hey, Ezreal's here. See that? She's good. Hi, Ronara. How are you doing? Thank you for coming and joining us. I hope you subscribed. You know, in NL, how you doing? NLPL. Nice to see you here. Prom, come on. How are you? Thank you for coming. Subscribe to SkyTour LiveStream. This is what you get. This is live. This is live. We're actually making this image as it's happening right now in the sky. With this telescope you see right there over here, it's live. You know, we control the camera from this system. It's a cooled camera dedicated to just doing this job, and this controls the telescope over here. Here is the telescope. Here is me. Hi. Okay, and I'm 2,500 miles away from that telescope. I'm running it from all the way across the United States. It's out in the desert in the west, and I'm in the east. So this is how it works. Hey, Bob Miller wants to see a globular cluster. Yeah, I think we can do that on the way back down. We can certainly do that. I didn't get to do what I wanted because we had a little snafu with the telescope earlier, but we fixed it, and it's working now. But we have a nice globular cluster we can probably show you. Actually, there's probably 24 of them right now that are visible. We use this system here while that's stacking. This is Stellarium. It's a free planetarium that you can grab and start using. It has additions too that you can actually get additional stuff for it with plugins and stuff. And we're currently looking in the constellation of Cygnus the Swan. This is the swan right here. You see the swan right here. There's his head and his wings, right? And so we actually see this beautiful, beautiful, beautiful constellation. And we're right down here near one of the wings, right? And I'm going to look at how many stack we have. I think we have about 24. Okay, good. Let's do 24. So we have a 24 stack stack here, and you'll notice that the thing that you care about is whether there's any noise in the stack. And when we look at this and zoom in and get a little closer here, let's do this. Let's zoom in. All right. We can see that there is very little noise in the dark spaces, and the filaments are looking a little better. So this is a stack that I think has reached its optimum best location. You're looking at hydrogen gas here. You're looking at oxygen, hydrogen and oxygen atoms in this gas, and they've been compressed against the interstellar medium as they expanded away from the star and hit the edge of the cavity that the star that created this has carved out when it was functional, and they were compressed and heated, and all these filaments are the result of this material being superheated. So that is the beautiful Eastern Veil. That's actually more colorful tonight than I've ever really seen it, Daryl. I think I'll process it to that, and I'll actually darken it down a little. In fact, let me just play with it right now to darken it down just a little. See if that.
Isabella asks, is it possible to detect any movement in the gases from here? I would wonder if in the case of the veil, maybe not. If it's 1,400 or 1,500 light years away.
Yeah.
And the veil supernova probably happened like 8,000 years ago or something, I think.
Yes, it did.
Debatable whether we could see it direct motion over time. There are some other objects like the Crab Nebula in Taurus, which is also a supernova remnant.
We've seen that.
They have actually tracked the cloud's motion.
Yeah, for 100 years.
Over the course of a few decades.
Yeah. For over 100 years, they've been watching it.
Yeah.
You know, and you actually watch the Crab Nebula expanding. You know, and it is a big universe. You know, It's a big universe and things are far away from each other. But it does look beautiful. I'm going to save this stack. This, of course, is not the full image. I mean, obviously, it just goes out above and beyond. And this will be available for you to play with. I'm going to have fun working on this guy, I can tell you that. So it tells you that we stack 30 images, but it's an equivalent of 12 minutes and 30 seconds of exposure. That's pretty good, you know? That's not bad at all. Okay, now... Okay, now I'm going to, I know I did it once, I'm going to do it again. Alright. So, you say, well, where does this hydrogen gas go? You know, what kind of places does it end up? Well, I can show you, actually. The next object that I show you is going to show us that. So we're going to clear this guy. Get out of the stack. I know, it's like, why? Don't make it go away. It's so pretty. Yeah, it really is. But I'm going to show you something else that's also pretty. And to do that, we're going to come back here. And all we're going to do is head a little bit toward the west right now. All right. And by going westward, we're going to see something else that's pretty neat. Let me just change my, let's get this, okay, 0.25, I want to go, we'll say 7, so do 1.5 degrees per second here.
Westward. You're going to Gamma Cygni, perhaps?
Yeah, perhaps true. Perhaps you're right.
Mark, Satisfying Animations asks, where can I find these images?
Yeah, on my Mark D'Antonio Facebook page at the top, there's a pinned link, and on SkyTour LiveStream on Facebook, there's a pinned link that is up there at the top that you can read, and just go click on it, and it's actually a shared OneDrive that I put out there. And you can look at the images from all the way back to July 30th that I was taking images on. That's when I started the whole thing up. So it's pretty cool. It's actually a very nice, a very, very nice way to get the images. You dig into the directories, and it'll be there. And while we're here, actually, let me show you this guy. If I don't miss my guess, I'm gonna go back to. And again, I'm not at 1 second for my exposures here. But let me just do that. Okay, I'm still at 25 seconds, sorry. I knew I forgot something. So we go 1 second here, and it'll look like there's nothing there, a couple of bright stars. Alright, in a second. So, an actual, oh, it's still doing 21 seconds. Why is it doing that? Made a mistake, that's why. Okay, that's better. So now it'll get black, and you'll say, hey, where'd everything go? All right, but then I can just do a hyper process here to just bring all the things back for the moment. And you see this guy right here. This is a very famous nebula known as it's called the Crescent Nebula. But it's actually a location where a very, very hot star, this star, in fact, actually, it's called a Wolf-Rayet star. That's R-A-Y-E-T, wolf, like the animal, Rayet. And they're very, very hot stars. Their surface temperatures are tens of thousands Kelvin, which is a temperature measurement that we use in astronomy. And again, very, very high Fahrenheit and Celsius, and they produce and blow off huge amounts of their atmosphere out into space, and they create bubbles around themselves, like this. This is what happened here. Okay, And
Thor's helmet's a good example of a Wolf-Rayet star.
that's correct. Thor's helmet, which we'll see in just another couple months, is an example. Hey Keith, how you doing? Keith here. We are like butterflies who flutter for a day and think it's forever. That's a really good Carl Sagan line. I like that. He was my favorite astronomer. Okay, so we're stopping there just to see the Crescent Nebula right there. Now we just have to go a little bit. Let me just bring this up again. All right, let me just bring up my stellarium. Right, and let me just drag this down a little bit. There we go. All right, so now we're going to go up north now a little bit. And by going north, you're going to see that we're leaving behind this area, but we're actually going to encounter something else. And this is what's interesting. We're encountering a very, very big nebula. And I asked a question before, where does this stuff go from these supernovae, right? Well, where it goes is places like what you're about to see, right? This is the star, that bright star you saw there in the view for a moment. That's a star called Saturn, or Saturn, however you want to say it. And it just happens to be the field star here. But this right here is what's called a diffuse nebula. It's actually a nebula that is the result of the supernovae distributing their gas, okay, to the interstellar medium. Okay, this is an example of where some of it piled up at one time or another. And just because it's gas doesn't mean it's not gravitationally attracted to things. Gas can certainly be, and it is. So when we look at it, we're looking at, for instance, this is hydrogen gas, and this hydrogen gas is very much on the list in the universe of material that is actually probably among the most prevalent. The hydrogen atoms are the most prevalent atoms in the entire universe. All right, so let's bring this back. I was sidetracked, sorry, by trying to just make sure I didn't go too far. So this is perfect right here. Perfect. Okay, so this is Gamma Cygni, Sadr, S-A-D-R, and this is the Gamma Cygni Nebula. And it's so cool. Now, you might say, well, look, two nebulas. Actually, it's not. It's one nebula. But this is a dark cloud of gas that is blocking your view of the nebula behind it. You want proof? I'd be happy to show you. So what we do is we're going to go in now and we're going to do another live stack here. But first, let's go make this another 25-second shot. Okay. And before we start stacking, because I want to show you what's going to happen then. Let me just turn that down a little bit. I don't want to blow out your ears, Daryl. Sorry. I do enough of that because I just don't shut up. Well, it's true.
Brevity is the soul of wit.
I guess so.
I don't remember who said that. I'll have to look it up.
Well, you notice I'm being quiet now because this is where you're supposed to come in and say something really cool. Look at that. Oh, man.
Yeah.
Let me just back off these guys. And then... If you notice what I'm doing actually is I'm applying different processing approaches. Okay, so this is, if it's a straight line, it's just no processing. So this is how it looks to the camera normally. Okay, but now if I want to try to actually add a little extra processing, okay, color wise we get that. All right, but then add processing to actually enhance the nebula, okay, now we get that. Now that is a beautiful nebula. And now you can see, and we don't need this here, we're going to keep stacking here. Now you can see what I mentioned before, and that is that this is actually dark material that's blocking our view. You know, you see that, Keith? Check that out. Isn't this sky beautiful? Look at this beautiful, complex structure here. It's absolutely astonishing. And you see there's knots of dark black dust here. Daryl, isn't it? This is stunning.
It is.
And this is with the full moon, man. And the moon's rising higher. It's probably like 10 degrees, 5 degrees, 10 degrees now. It's waning, but still, as it gets smaller and smaller, we're going to keep doing it. Now, I want to show you something now. We've only stacked, let's see. We've stacked 4 images so far. So, let me just show you something here. If we zoom in to 100%, I want you to notice, all right, in the dark areas, okay, you see how this looks kind of noisy in here? I mean, you can see some beautiful detail, but it looks noisy. See the colors and all that? Yeah, that's awful, okay? But by stacking over time, and it's doing it right now, it's live stacking while we're watching, okay? In fact, we're up to 5 frames now. You look down here, it tells you 5 frames stacked, 1 ignored. And as it stacks, you're going to see this gets less and less and less of a problem, just like with the veil. When it gets to about 15 or 20, this is going to look really nice in here. So let's just pop it out again. This is actually almost directly overhead. That's the other thing too. The Gamma Cygni Nebula is almost directly overhead right now. So we're going to see lots and lots and lots of detail. Without a doubt.
It's interesting. Just about due left of solder.
Yeah.
Near the center of the image, looks almost like a black tornado. That right there.
Yep.
Yeah.
Yep.
And that is in front of the red stuff.
That's right. It's blocking the red stuff behind it, the red glow. Yep.
Yeah.
And don't forget, this is in 3D. We don't know what this really looks like. You know?
Yeah.
But it is in 3D.
It's interesting that the point of the that funnel shaped cloud is like really close to that star. I suppose that's just a chance alignment, or the star is probably a foreground object.
Yeah, I think so. Most likely a foreground object. And the black cloud could be, the black cloud's a foreground object to the red cloud behind it.
Right. 3D, as you said.
Yeah. And, you know, as I've said this to Daryl and a lot of other people, and Daryl knew this, you know, when we look at the sky, we're seeing it as it once was. We're not seeing it as it is. We never do. It's always seeing it as it was at one point in the past. You know, for the veil, we're seeing it as it was 1,500 years ago. For the star Vega, we're seeing it as it was 26 years ago. For our sun, we're seeing it as it was 8 minutes ago. So the universe is vast, but we also know that there are many objects out there that really, you know, I mean, we saw the black hole in the Virgo galaxy, the center of the Virgo galaxy, right? Well, we're seeing that thing. We're seeing it as it was tens of millions of years ago. You know? And that's just amazing. Let me see if I can just enhance a little bit here. And these look like physical clouds, don't they? Let me actually, let's do this. Yeah, see, that's, this is called a stretch. Okay. All right, let's do this now. Let's pull this over.
If they're red, I assume it's hydrogen emission, therefore something is exciting the hydrogen in the clouds. Would
correct.
that be solder?
Other
stars in the area?
It could be solder, yes. You know, This is an interesting cluster up here. I forget, is this measure 39 or something?
I think you're right. M39 is in Cygnus, so I'd have to look it up.
Alright. Well, actually, I can just go look at our little handy-dandy planetarium. Let's take a look. Sorry, I gotta take a drink. Alright. So there's a cluster we're looking at right there. And let's... Sorry. Man. See, it's at the zenith, so it's really it's hard to get it in here. It seems. Okay, so is this the cluster? No. That might be it though. That's M29, but I don't think that one's M29. Might be this guy. Might be the inchworm.
In the Stellarium view, you've got that dark band just above solder.
Yeah.
I assume that's the same dark band you're seeing in the image.
Yeah. Yeah, and this cluster's on that side of it. So that means that must be the inchworm cluster over there. And measure 29 is outside here. Look at this now. Look at this, guys. Wow. This is just amazing. You can almost see three-dimensionality here. And of course, it's just your mind projecting it. We don't really know. See, Vera says it, She says, I can't wait to see images without the moon. Now you understand my excitement. Yes, now you see it. Look at this beautiful nebula. And this is with a moon. Oh, ay. I don't know, this is just crazy. It's just beautiful. Okay, we've stacked 17. We're going to go to 20. As we speak, these are probably already up on the cloud, the raw images. But keep in mind, the raw images are just PNG files, and you don't stack those. So I'm actually saving the stack. Right, so they're already stacked when you get them. And they're in actually an astronomical format called FITS. F-I-T-S. Okay, 18, 19 frame stack now. One more, and then we'll pause it and save everything. I think this is more pretty than the last one I did, actually. Of course, I'm also going at 417 gain on the camera, so that's pretty high gain.
SEA 39 is 9 degrees east-northeast of Deneb.
Okay, that's right.
2 degrees south of the star Pi Cygni.
Geez, while I'm here, should I do the North American Nebula?
You want to.
you know you want to.
I know, you took that cool image of it the other night, and then you came back and said that the moonlight had harshed the image.
Yeah.
I don't know if it'd be better tonight with less moonlight.
Well, I'm going to try it. Well, did I take the North America the other night?
Well, yeah, it was the Pelican, and then...
the Pelican, that's right, you're right.
Yeah, we fit the Pelican's head and the Cygnus wall.
Yes.
In the same image.
That's right.
Coast of Mexico on North American Nebula.
Wow, look at that. Look at this little tiny spindle of black dust here. This is beautiful. Ah, yes. Okay. Goodbye. Cleared. Clear. Okay. So now we come back. This is why astronomy is so exciting, guys. It is absolutely just heart-stopping sometimes what you can see. It's literally heart-stopping. Let's hope not for real, but you know what I mean. Alright, taking 1 second photos now. That's not a 1 second photo. That's the remnant of the previous. Right. Oh, I forgot to shut off the stack. I'm sorry. Okay, we're going to clear. We're going to pause. Okay, clear. And shut down stack processing. There we go. So, jeez.
Brevity is the soul of wit. Is Shakespeare, of course.
Well, you didn't know that before.
It's from Hamlet.
Okay. All right. Let's There's so many things to see.
Interesting. All the nebulosity around solder there.
Yeah.
In the stellarium looks almost square.
Well, yeah, that it is here because they cut it off at a certain point. So that's the only reason. It's the only reason. It's not really square. Well, you know that, of course. All right, so let's go here. Spin this around. That's where we're going. Okay. So let's go. Gonna move a little bit to the east. We take our spacecraft and move it to here. Excuse me for coughing so much. I apologize. I've just been talking so much to you guys because I don't believe apparently that brevity is the soul of wit. Just too exciting. Okay. So there. Alright, and now we're going to head north a bit. And you'll see over here, you should see the nebula coming in. There it is. That's the wall right there.
Yep.
The wall is a section of this. There's the pelican. Actually, we almost got it exactly where we need it right now. So I'm going to go down to a slower speed and stick it in here and drop it down just a bit and then move it over just a bit. That might do it. A little more.
Aja asks an interesting question. Is the Hubble image also stacked? I might say first, of course you can jump in on it.
Yeah.
They take very long exposures with the Hubble, Ojo. And I don't know if you'd really call it stacked in the sense like Mark is doing it. They can accumulate many hours of data and go back and pull it up later and combine them all, via the computer.
And they do. So effectively they are stacking them.
Yeah.
Yeah. Okay, we're gonna get rid of this here. This is the entire complex. This is the North American Nebula. This here is the Gulf of Mexico. This is Florida. This is Mexico. The Cygnus Wall is the west coast of Mexico. That's why it's called the North America Nebula. And this is the Pelican. It doesn't look like anything now, but let's just have some fun and let's first drop it down to just what the stars look like if you're looking through like a pair of binoculars. And then let's go up to our favorite 25 seconds. I was doing 60-second shots the other day and it just came out beautiful. But I don't want to make you wait 60 seconds. So we're going to do this. It's going to start going. And then we're going to live stack this. Alright. And
Oh, Joe, if you ever saw the image of the deep field by Hubble, they pointed the Hubble at a little blank area of sky,
Mm-hmm.
and they exposed it for weeks to build that image.
So yeah, no, they're stacking, but the way that the Hubble's so precise that they can actually put it back to exactly where it was before, within an arc second or two, I think. And then what they'll do is they'll take that and they'll be able to use that to literally. Oh, stacking is paused. Duh.
Ricola.
Yeah, I know. I definitely need that. Okay. I had paused the stack. That's why nothing was showing up. My apologies. So we're starting again from fresh. Watch this. This is just. You know, as many times as I've seen it, it just doesn't get old. It just doesn't get old. Oh my God! Look at that.
Yeah, that's great.
That is just a photo and a half. You know. Here's the pelican. Look at this beautiful red area here. It sort of looks like a pelican. And here is this cloud down here of hydrogen gas, also with dust. This is black dust blocking the view of the nebula behind. Isn't that just stunning? Let's see if I can.
This one too, the brighter red parts, like on the back of the pelican's head.
Yeah, right there. Yeah.
That just gives it a very three-dimensional look.
It does. Well, it is three-dimensional. We're just seeing it projected on the sky.
Sure.
I just dropped it down. This is a beautiful picture. Wow. Beautiful.
Welcome back, Isabella.
Hi, Isabella. We were talking about you again. All right.
She took her dog for a walk.
Oh, really?
Yeah.
What kind of dog do you have, Isabella? I'm going to guess a brown lab. I don't know if you do, but I'm going to guess. That's just a guess. Let's darken this a little bit in the areas down there. See what we get. Yeah, no, I like this a little brighter.
I watch pet rescue videos on YouTube sometimes.
Yeah.
And there's one channel. They're over in Eastern Europe someplace.
Wow, look at that.
Some of the dog breeds they have, I mean, they're like nothing I've ever seen before.
Wow.
They're huge dogs.
Oh, I've seen those. They're like the Newfoundlands on steroids. They're even bigger. They look like bears. Right? They're the size of bears?
I don't know about bears. Some do. There was one in particular. He was short-haired, but he was. She has a golden retriever.
Oh, okay. I was thinking of brown.
Golden retrievers are the best.
Oh, I said brown lab. Yeah, okay. My dog Indy, who unfortunately passed away last year, she was a golden mixed with a pit bull and a shepherd. The mother was a pit bull shepherd. The father was a golden. And she came out all black with white chest and white paws. And she knew she was beautiful. She knew it. And she used it. And she won every time.
My dog, Bub, B-U-B, Bub.
Yep.
He was half Chow on both sides.
Okay.
His father was Chow German Shepherd. His mother was Chow Border Collie, if I remember right.
All right.
And he came out, he weighed 110 pounds. He was beautiful, kind of not quite Irish setter red, but he was kind of a reddish brown color with a white blaze on his chest. He had some white marks on him. And he didn't look like a Chow, but there was something about the shape of his hips. People would see him and they'd go, "Is he part Chow?"
Really?
And he was a very handsome dog. a heck of a dog. If I ever had a kid, that dog was my child. I lost him to cancer, oh gosh, 22 years ago.
Wow.
He was a heck of a dog.
Yeah, I used to have greyhounds. I rescued them from the track, you know, and they were great dogs too, but they always thought they were lap dogs.
Yeah.
They would literally try to come up on the couch and sit on my lap, and it's like, your legs are longer than mine. It's like having pet giraffes.
Many years ago, I used to go to the dog track and watch dog races.
Sure.
And I quit doing that. But oh gosh, one night they would walk the dogs out before every race, you know, and show them off to the crowd. And there was this one greyhound. He just did not want to be there. The handler had to drag him by his leash all the way out, all the way back, and the dog was resisting every step of the way. And well, they loaded him in the starting gate for the beginning of the race.
Yeah.
And the bell went off, and here came the rabbit, and the gates flew open, and the dogs all jumped out. And this one dog, he went about 10 or 15 yards. Then he did a 180 and headed the opposite direction. He ran around the back corner of the track, and he jumped over a gate at the back of the dog track and disappeared into the night. That poor dog.
Actually, if somebody found him, they probably rescued him.
That could be.
Look at
I
this
know
picture.
you see that a lot nowadays, greyhound rescues.
Look at this picture.
Oh, that's excellent.
And we have a moon out, guys. Wow. Wow. Aye. That's all I can say. Aye. Look at these filamentary structures here. Look at this beautiful cloud. It's like looking at a cloud in the sky, guys. So beautiful. The Cygnus wall is really stunning. It's that feature. And this stuff's moving. It's moving around. It's just that you can't really tell. You know? But look at this. Wow. Wow, indeed. Okay, so we have 16 frames stacked here. I hope you guys like playing with this one. You're gonna get a picture that looks just like this too, by the way. And you can take that. It's a ping, and it's gonna be literally 4,244 pixels wide by 2,822 high. So it's definitely gonna fit on your computer screens, or even more. It's more than 4K resolution, actually, in terms of, if it was a video, it'd be 4K resolution plus.
That's great, Bert.
It's just stunning. Wow. Let's go back to the histogram and see about what we can do for... let's bring the black level. The black level is what I want. Let's take the black level this way a little bit. Yeah. If I go too far, see, it disappears. So we don't want to go too far. This, by the way, this processing is not destructive to the stack in any way. It's all good. So this light area in here should be actually black. It looks light because of the fact that the moon is out, and that's the only pollution that's in this from the moon.
Well, there is some nebulosity in the dark part.
Yeah, there is. Yeah. That's actually what I'm trying to kind of highlight here. But you gotta let it stabilize over a few frames. Look at that. Wow. 21 frames stacked, and I'm beside myself. I can't believe it. by the way, just so you guys know, I said I was going to go for about an hour and a half. 2 hours and 37 minutes. And climbing.
Yeah, I'm going to have to call it pretty quick.
Oh, you can't go. No freaking way, man. Not with these things on the docket here. That's true.
Well,
That's
maybe
all right.
one more object.
This might be the last
Sounds
object.
familiar. Just one more.
I know that's my model. I was gonna stop at Gamma Cygni, but then it was like just one more. Yeah, we're gonna go to 25 on this and then be done. Maybe 23. Okay, we'll pause it here. Okay, so it's paused. Now we're gonna save it. You'll see it stay across the top. It's saving as a fits file. Then we're going to bring it up again. Then we're going to save it just as you see it. Okay, and that's gonna be good. And then that'll tell you where it's saving that too. Took that as well. Oh, Isabella, yeah. I get nothing done when I do the processing. I mean, I literally, I have other work to do, right? But when I have something like this, look at this. Ah! It almost looks like it's processed as good as it can get, but it's not. Okay, for instance, this central glow, I'm going to get rid of. I'm going to tone that down and make it even with the rest of the picture. That's called a flat field. I don't have a way to do flat fielding stuff here because flat field is usually like an attachment you put on the telescope to put an even light across it so you can actually calculate the flat field. I actually wrote a program to make a synthetic flat field because, I mean, the idea is to try and figure out if there's any spots on your sensor or in your optical system where it's say dark around the edges, okay, like it's dark at this edge over here and it's dark at this edge up here, okay, and if it's gonna do that, then you can actually subtract that out when you're doing the processing and remove all the bad stuff that shows up sometimes, and that's a flat field. Well, I could, I did this already. I mean, I had a cover on the telescope that was automatically closing the whole telescope and opening it. Well, I don't need that anymore because I've got this long dew shield on it, and the dew shield doesn't have a problem, doing this. Oh, Isabella, you saw the show with Avi? Yeah, Avi Loeb, is a Harvard astrophysicist, and he's a nice guy, and I'm probably gonna have him on my show. He actually told me he'd like to go on my show now too. But he's actually started a project called the Galileo Project, where they're using telescopes to look for anomalous behaviors in the sky. And he's got a lot of people signed on that are pretty cool. And he asked me for some of my input too on it, which is really nice. So I'm going to talk to him about it. He's like I said, good guy. Really good guy. Okay, so here's our 1 second shot.
I didn't know if I'd known I would have listened in. Was it on KGRA or somewhere else?
It was on KGRA, Martin Willis's show, and Martin asked me to be on with he and Avi and then Ted Rowe. I ended up getting an invitation to Hawaii. Of course, I gotta pay to go to Hawaii, but so I don't have any options right now to do that. But I thought it was pretty cool. Oh, Elephant's Trunk, I'm coming for you. Not today, though. I will be back. You have defeated me tonight, Elephant's Trunk, but you will not defeat me again. Don't give me that sad music, Elephant's Trunk. Yeah. Alright. Oh boy, I'll tell you. Just head south now. Well, the telescope knows where it is. I set a park position. I'll try to park it and see if it works. That's a scary thought. Because I did set a park position.
Are you calling it a night?
Yeah. Let me just get this out of the way so I can make sure it's not going somewhere it shouldn't. Okay, that's the park. That's correct. Alright, and the controller says scope is parked, you can turn it off. I could actually hit the unpark right now and bring it back, but I think we've done enough, and I've been kind of, going by the seat of my pants tonight because I've been a little worried about this. I'm going to turn it off now. You'll see this controller now go off when I hit this. Okay, so there it is. Telescope's off now, and that opens up the safety, so I can now shut the roof. I couldn't shut the roof before, so if you watch now, actually, let me actually just show you how it works. Why not, right? And let me just make it a little bigger. Alright, so now when I go to shut the roof, it looks very much like this. And I just use simple numbers like this because it's easy, and I wrote it to do it that way. And when I hit this, you'll see the roof now close over the telescope. I just think that's the coolest thing,
Oh.
Yeah. Okay. Well, there we go. And I'm just going to now come back in here. Disconnect the camera. And kill that. Alright, and then this is like the music saying, okay, we're done for tonight. It's like this is the we're done music. Alright, let's see. And then Stellarium is going to disconnect. Indeed, it will.
You got a feather duster in your observatory?
That's a spider web, and that's going to be one of the things that I get rid of when I go out there. I got to be careful, though. It could be a black widow.
Have you got a feather duster?
I don't, but I have my hand. I just crush and grind up black widows. No, I don't do that.
Right.
Who does that? Not me.
Or get you a dustbuster or something.
I just need a rag to just wipe that off, I got a number of cameras in there, right? So, it's kind of important to keep them clean, I guess. Okay, that's done. Close APT. Okay, and only thing left is to close this, and we're done for the night. Well, I hope you folks really enjoyed this, because I really enjoyed this after the few moments of just downright bitterness at myself for not knowing why it's doing some of the things it's doing. But we brought it back and we viewed some beautiful nebulae. I think that's pretty good. Right now, as far as where the moon is actually, let me tell you how high it is in the sky. I can actually figure out. The moon right now is actually 44 degrees up in the sky, so it's like that. It's pretty much up there. So it would be quite a problem for us. Keep in mind what's coming up is the Pleiades and the Seven Sisters. We've got Orion coming. We're gonna have Auriga coming up too, which has some really cool clusters in it. And in up in the north, we have the double cluster that's going to be up there. Right now, the double cluster is actually over 40 degrees up in the sky. It's stunning, looks beautiful in this particular scope with this particular setup. And the Andromeda Galaxy.
Fit the whole thing in the field now.
Huh?
I bet you'll be able to fit the whole double cluster in the field
easily.
now.
Yeah.
Yeah.
And right now, the Andromeda and Triangulum galaxies are really high in the sky, but we can't see them very well because they're actually sort of near the moon. You know, maybe a few degrees, some degrees from the moon. So that's not good. And after, the other thing too, after this goes away, after we get past this mess, we have to keep in mind that we also have a wonderful nebula to look at. Actually, a couple of planetary nebulas. We have the Saturn Nebula, and then we have another one just a little bit east of it called the Helix Nebula.
Yeah.
And the Helix is low in my sky here, but it's 35 plus degrees in the sky out there where the telescope is. So it's going to be pretty high in the sky for the telescope, and I imagine we're going to get unprecedented views of the Helix. Keep in mind that when I see things like that for the first time, I could literally sit here and just blubber like a baby. It's just beautiful. So you may catch some of that and then, you know, get out of SkyTour LiveStream because you don't want to be associated with that baby. But that said, I think we did okay for tonight, Daryl.
Yeah.
we got it all lined again, and it parked fine. Not sure what caused the problem, but I'm gonna research that some more. I'm also looking at maybe another control program. I'm thinking about maybe getting Maxim DL to control this, and that would take a lot of this out of the equation. But SharpCap is the one that does the live stacking, and I don't want to lose SharpCap. I think SharpCap is really good, but APT might have to go if you know, because the only thing I use APT for really is for doing the movement to the telescope. It makes a nice presentation on the screen, right? You know, but it doesn't. You know, I should have another way to do that, and there are ways. I mean, SharpCap can move the telescope, but I've not used it. I've tried to connect it, tried to make it work, and as Daryl and I saw, it didn't work. But that's all right. I think we're okay now, at least for the next time. But happily.
Tell Crystals thanks, Mark.
What's that?
Tell Crystals and Cats thanks. She made a nice donation.
Are you serious?
Yeah.
Oh, Crystal, thank you so much. I just didn't see it. I apologize. That's very nice. Thank you, hon. Thank you so much. That's wonderful. I really appreciate that. You help me keep going. You help everybody keep going. Thanks, Daryl, for letting me know. I wasn't looking at that. I was looking at the screen to make sure that everything was shut down fine.
Sure.
Oh, okay. And Isabella says she got this plugin that I told her about, which allows Photoshop to read these FITS files we're talking about. And she got it. She took the chance, and it works great. I told you it would. See, I told you. You know, trust me. That's good. Oh, I didn't say hi to you, Fantasy. Hi. Nice to see you, Fantasy. And Laura Newbert. I missed you too. I'm sorry. It's so nice to see you guys here. Boy, Crystals, that was very nice. Thank you so much. That's very, very kind. Well, you know what? We're gonna head out. So you guys have a good night. Thank you so much for being part of this. We'll see you on the next clear night, and trust me, we have over 300 of them a year out there. So I've got to start actually honing down. In other words, I don't like tonight. If the telescope didn't go haywire, there were 3 objects I was going to look at, 3, and then we're going to be done. So I'm kind of doing that kind of thing. Make it like 3 objects in a night session, depending on what we're doing, and do the stack and get them ready for you. But see, the thing is, you're gonna get the process shots too. But you guys have a good night, and I look forward to seeing you on the next night. And Daryl, you're free to join me as well on those next nights as well.
Oh yeah, give me a holler.
I will.
Good
All right,
night,
guys.
everybody.
We'll see you later.